Alright, you should be able to see my screen now. Code is blue. Blue. Welcome. Alrighty, so yeah, this was the PowerPoint I was doing the other day. We're making a PowerPoint on future of tech. So your topic could be anything you want. So let's just say my topic is about future of technology. And I chose this just because I feel like this is some relevant information you guys should know. Um, so since last week, I just added this image here. But that's about it. And this, and I deleted that. The other image that was kind of irrelevant. I was showing you how to make the rest of a picture black and white. So now adding a couple more slides. I don't think I have any more special features to go over, how new animations and all that. Let me see what this looks like so far. If I do slideshow from beginning, we got some swiping or wiping animations. We got this where it makes the text bigger, grays it out, makes the next one bigger, makes that one smaller. And we got this sliding up. And for this one, I didn't add any animations yet, but maybe for this one, since I'm talking about something incredibly small, I'll add an animation where it zooms in like that. I think that would make sense. Okay. All right. So for the next thing, um, so this, by the way, is called Moore's Law. Some guy with the last name Moore came up with it, or he thought of it. He said that microchip architecture is gonna, it's gonna get smaller, or it's gonna the number of transistors you could fit in a chip is gonna double every 2 years. And he's been pretty accurate, but now we're getting to the point where it's so small that there's like these little gates that electrons are supposed to pass through in a microchip, but it's gotten to the point where they're so small, they're only a few atoms wide, that electrons just pass through it even though they're not supposed to. It's so tiny that they just um, jump right through. So it's harder to get much smaller than what we have it now. So Moore's law might be dead. Um, and then for illustrating that, I thought we could maybe create a chart to show the number of transistors that we have in microchips and how it's changed over the years. So let's maybe I don't need a title for this. I'll get rid of the title and I'll just make this bigger, and I'll insert a chart. So to insert a chart, if you don't have this here, you can always go to insert and then choose chart. And we can see here, I think for this, I want a line chart, something like this. So I'll say OK. And when you're inserting a chart, it's going to come with some dummy data. And also you're going to see some stuff highlighted here in purple and in red and in blue. And you can see here it says category 1, category 2. So the categories will be listed on the bottom. And then here we have series 1, series 2, and series 3. So the different data that we have. in different columns. So the series is going to be up here. That's the name, but we can change it. We could, for example, if we're going to be talking about the number of what do you call it, transistors inside a microchip doubling every year, every 2 years, you could say, maybe this would say the year. So maybe yeah, year. Actually, no, sorry, that wouldn't make sense. This would be the year, and then these would be dates. So, or years, I guess, 1997, 1999, 2001, 2002, 3. And maybe this would show the company, maybe that made it, Intel. And what's that? There's a really big chip company. I keep forgetting. It has an acronym. I think it's Taiwan Chip Company. It's maybe, I don't know. I forgot what it was called exactly. But let's just write Intel for this. um, and then for the graph, well, why do these all say 2000, 2500? Maybe if I change these numbers, it'll make more sense. Let's say like 2000 million, then 4000, oops, then 6000. And you can see as I'm changing this graph updates. 8000. So now it's making a little more sense. So where does it say year? Year. Oh yeah, the blue one is the year. And this would be number of transistors. And then I guess we don't need a third category, so you could pretty much just delete that third category. Did it go away? Nope, it says column 1. Let's delete that. Okay, it's not letting me delete. Maybe I have to select my table again. I lost that little indicator, the one that was showing. I don't know how to bring it back now. Maybe I have to do that. Well, it looks like I deleted it, so yeah, so now it's just year and number of transistors. So we have a graph that shows the number of transistors on the left side, so 1000, 2000, 3000, 4000. I mean, it's much bigger than that. It's actually like 9 billion, not 1000. And then the year on the bottom. We should, well, where does it say 1997? That one doesn't really show. I might have to reverse it, put the dates on this side. That would make more sense, because you don't, well, let's close that. And if you close it, you can always right click on the graph again and then edit data. It should open up again. All right, there we go. So now I've got that little blue box again. Not sure why there's still a category 3 and 4 though. Thought I got rid of that. Oh, That's why. Intel. So these would be the different companies. This would be the year. But I'd rather have it so maybe it has the year here. Let's see if we can do that. Delete these, put the year. Um, okay, that makes more sense. 1997, we had that many transistors. 2003, we have that many. That makes a little more sense, I think. But we could get like the real data. I could go to Wikipedia probably. Transistor density over time. And there's already probably graphs out there that show it. Yeah, like these, for example. It shows transistor density relative to mini computer back in the 1970s. So there's obviously an increase, and it does go with Moore's law. You can see here it's been doubling every 2 years. Um, so what that means is computers can do well, take pack more data and work faster. The smaller the transistors are, the less electricity and power they use, and um, the less they heat up, so they can actually work faster and do more and hold more data at the same time. But let me see if there's a source like this. What does this say? So it's got a year. It's got transistor count. I guess I could use this as my data. But it's kind of hard to copy just what I want. Maybe I could copy the whole thing and then just delete what I don't need. But then there's also a lot of like question marks in there. I don't know how those question marks are gonna show up. I guess I'll delete those too. But let me copy this, and I want to use it for. Oops. Oh no. Okay. Copy all of that, and let's paste it. Oops, not here. Let me close this actually and open it again because I want to see. Oops. Edit data. I want to be able to see these the areas, the red, the purple, and the blue. I want to paste into that area. So maybe I'll just delete all of this and paste over it. And looks like I didn't copy much. Where's the rest of the stuff I copied? Make sure I got all of it. That didn't copy all of it. Highlight this again. I guess they got a separate list for GPUs. Right now, this is the list for CPUs, I guess. Back to PowerPoint. Paste. There we go. All right, so now I have to modify this, the area that's gonna show up. So I have to highlight. Well, first let me delete the irrelevant data. So I guess this first two columns we don't need. So delete. Yeah, delete. We don't really need. Well, this one just shows the name of the manufacturer who makes it. This one's the name of the chip. We don't really need that, so I'll delete that one. So I found a problem. Okay, wait, I think because I deleted, oops, the only row that, or the only column that has the purple, so I should probably, I don't know why that keeps popping up. Oh, another thing, when I pasted all of this, let me paste it one more time. When I pasted it, I forgot to say paste special. I don't really want all that Wikipedia formatting in there, so I'll just say, if I paste it as text, it says inserts the contents of the clipboard as text without any formatting. That's how I want it, so I don't have any links and stuff. So delete this column. Let me expand all the columns, make sure I can see everything. We don't need this one, but this is the only one that has the purple, so I'll move that purple over to this side. I guess I can't move it. Let me just delete this then. Delete. And we have the rest of the data. Well, I don't know. It got pasted in all weird. There's two different data in one column. That's not good. So scratch that. I guess I just need to find a better place to copy paste this from. Um, but whatever. For now, I guess just so we don't waste time, I'll just put dummy data or just do it by hand. A few of these. Um, go all the way back down. Let me just delete everything. We lost the purple box, so might as well just delete this and insert it again. One, and I'll just leave it as the dates here. 1990. Let's say it started in the 1970s around, and from there we went up to. Let's just skip a few years. 2000, 2010, and we could actually add maybe 2020, the latest, and expand this to include that data as well. Stir density. And maybe this will just show manufacturer. And this we don't need. Okay. And of course, I'm just making up random numbers, but just showing that it's increasing. And then these would be names. Like Intel. Um, Anyways, so yeah, you could create a graph like that to show some data. And maybe for one of my slides, oh, and by the way, we can style this graph. We can choose chart style and choose any one of these other styles. So maybe I want to choose this one. And you can also change the type of chart. Change chart type. We can change it. I'm not sure if it's gonna replace the data. Let's say we want the one with the dots. Say okay. Uh, yeah, it did. It's hard to tell the difference. Let me change it to something more obvious, like a column graph. There we go. So you can always change it by right-clicking on it and changing the chart type. And you can always add data or edit the data inside. I'm not sure. I mean, there probably is a very complicated way to animate the chart rising, but I haven't really looked into it. Let's see, can we select the line by itself? No, I doubt we can animate the chart. That would be cool if we could do that. But yeah, these are two basic. There's some motion paths, but no, I don't think those would help either. So we'll just assume that it's not possible. Okay. All right. So now I want to insert maybe a video, and I don't know if this needs this thing. So I'm putting it on pretty much every page, so maybe I should just copy it just to keep it consistent. Put this on the side, and then we could pull this a little bit this way. Oops. Make sure I grab the whole thing. Copy, paste, and make sure this is all the way in the back, so send to back. So this will be on top of it if it needs to be. Of course, I could always resize this if I don't want it to overlap. You can also stretch it out more and maybe not do that, but I'll just make it bigger. It'd be nice if I could fill this background with this color, but when I drag this, it brings these numbers. Actually, I could do this. Probably drag this way. Nope. I guess it doesn't let you. Double click. Nope. Oh, there we go. I could just drag it from here. That works. And then I'll send this one to the back instead of the other one. There we go. I think that looks a little better. And if this is too high, just drag it down. Drag this up. And drag this way. Alright, that looks better, I think. Covering the whole page. If you guys want to try adding a graph, messing with it, give you guys a couple minutes to do that. And let me know if you have questions so far. Yeah, AMD, NVIDIA. But there's a really big one in Taiwan. They're the biggest right now, I think. I'm sure they'll be on this list somewhere. Qualcomm. Qualcomm's pretty big too because they're doing phones. Let me just Google it. I don't know why it doesn't come up here. Microchip manufacturers. There's Intel. Oh, there it is. Taiwan Semiconductor Manufacturing, TSM. Qualcomm, Broadcom, Micron Technology, Texas Instruments. Those are the ones that made all those calculators. Nvidia, Ace, STM. Guess those are the biggest ones. So Intel is still the well, they have the biggest revenue. Anyway, so every couple years they double the density of these um, chips. If you look at Intel's, or let's go to Intel products. Um, so you look at their chipsets. Let's say, let's go to products. I don't know what the difference is between all these different ones, but let's refine it by the release date, which it already is. So I guess this is their latest one, the Q470 chipset. Status bus speed, number of DIMMs, USB ports. I guess it doesn't say here. Intel CPUs. There we go. Okay, so from the CPUs like the i9s, the i7s, um, they every year they increase the number. Like right now it's at 1160, but older ones like my computer, if we look at it, um, go to C, or actually right click on this PC properties. We can see I have the Intel 8700. So if we're at 1100, that means this is a 3-year-old chip. So there's three newer generations than the 8700. There's the 9700, there's the 1000, now there's the 1100 series. So every time they release a new series like that, they make the chips smaller and smaller, or the architecture smaller and smaller. And you can see here it says 10 nanometers. So that's the size that they're at right now, 10 nanometers. And I think 1 nanometer is like one atom. So 10 nanometers, that means they're at um, really tiny size, only 10 atoms wide for their transistors, or the transistor gate. I don't know. We'll look at a video right now so you kind of like get what that looks like. Um, and if you look at Intel 8700K, that's the one that I have. It's probably going to be a lot bigger. Let's see. Yeah, well, not much. It's 14 nanometers. So now it's 10, but it was 14. But I've heard like Intel's been having trouble making their chips smaller and smaller. But anyways, I prepared like a YouTube video. This one, I thought it was kind of cool, so I'm going to copy this, and I want to insert a video into here, so I'm gonna go insert, not picture, where's video? Insert, where's video? Video. Media, there we go. Video, online video, or from my PC. I'm gonna choose online and enter the URL. I'll just paste this in and insert. Okay, so there's that video from YouTube. I just copied the link and I inserted it here, and I'll just make it cover the whole page. So after this, we'll go to this to just show, what that microchip looks like. And I want you guys to watch this too, so I'm gonna do this on watch together. And it's not long, it's like 4 minutes long.
Grammarly does more than catch errors. With Grammarly, you can find.
So we've done watch together enough where you know how it works already, right? I'm just gonna send you the link. You're gonna click on it and you're gonna be able to join the room and we can watch it together. Otherwise, if I just play it on YouTube, you're not gonna hear the audio if I'm streaming it like this. So you gotta go to the watch together so we could watch it and hear it together. So click on that link and join the watch together room. Okay, so a few people joined. Waiting for more. It's not really difficult video. I mean, it's not like instructions or tutorial video or anything. It's just a video that kind of goes through how microchips are made by Intel. It's pretty interesting. Okay, we got that's enough people. 1, 2, 3, 4, 5, 6, 8, 9 people. Okay, I'm missing like 2 or 3 people, but that's okay. Let's just watch this. Uh, sorry, that's definitely not it. Um, did someone change it? It's supposed to be this one. Oh wait, it's down here. There it is. There we go.
The world is producing data at an unprecedented rate, faster than our ability to analyze and understand it. To move, store, and compute all of this data requires incredible processing power. From the blazing speeds of our devices to blazing trails within AI, Intel builds chips that are at the heart of nearly everything. Within every Intel chip manufacturing facility across the globe, innovators are pushing the limits of science and literally rearranging atoms to create groundbreaking technology. This strong silicon foundation is what gives each Intel chip limitless potential. At the heart of all modern electronics, the transistor is a tiny switch, 10,000 times smaller than a human hair, that controls the flow of electrons through a circuit. To build a processor, billions of transistors are packed into an area no larger than a fingernail. It's one of mankind's most complex feats, and a remarkable achievement that Intel has essentially doubled transistor density in every new generation of processors. The process begins when silicon-rich sand is melted and cooled, forming a solid, which is then sliced into wafers. Once inside an Intel fab, the raw wafers begin their long journey through an incredibly complex process. They're loaded into front-opening unified pods, or FOUPs, which travel hundreds of miles along Intel's automated superhighway, going from tool to tool, as processors are painstakingly built up on each wafer. The wafer first goes through a series of important steps, such as photolithography, ion implantation, and etching, that prepare it for the critical transistor formation process. Intel was the first to manufacture three-dimensional transistors called FinFETs. FinFET construction requires first building a channel in the form of a fin. Intel has devised several innovations to overcome fundamental barriers to continued transistor scaling. One such innovation is a breakthrough fabrication method called gate last. It involves building, then removing a temporary gate in order to precisely place the dielectric material and metal gate. This allows for the gate to wrap around the fin and control the flow of electrons through the channel. Another invention moves the transistor contact directly over the active gate. To accomplish this, the gate material is recessed and then filled with insulating dielectric material to prevent the creation of a short circuit. Next, the dielectric near the gate is etched, filled with metal, recessed, and capped to allow a novel self-aligning process that enables the high-density contact geometries. Now, the dielectrics are etched selectively to expose only the desired part to connect to the first metal lines. This is done through an innovative via etch and deposition scheme, allowing contact over active gate to happen. Finally, dozens of layers of metal interconnect lines are added to complete the circuit. After more than 1,000 of these complex steps, the wafers are finally prepared for singulation and packaging. Innovative processor packaging has become a critical feature of advanced computing architecture. 2D and 3D packaging technologies are enabling new device form factors and additional boosts in performance and energy efficiency. Testing of the final product ensures that every chip exceeds our performance and quality standards. In addition to adding more performance and features with each new processor generation, Intel's integrated design and manufacturing capabilities have enabled humanity to innovate game-changing technologies that impact nearly every facet of modern life. Intel keeps powering the world. At the same time, we're powered by you, the makers, the dreamers, the doers, the people who share in our history of making the world smarter, faster, and more connected.
All right. Um, yeah, I don't, I don't expect you guys to understand how the whole transistor works at that level. I don't understand it either. But maybe you do. Maybe you're smarter than me and you got that. But you kind of get an idea of how tiny these things are. And yeah, Nvidia is one of the leading companies, but Apple recently, and also not just Apple, a lot of other chip manufacturers, they've gotten them. Well, they claim they've gotten them a lot smaller. Um, so this just came out like a week ago or something. It was the Apple. I think it was called the M1 or Apple. Yeah, it's the new M1 chip. Um, and it's supposedly 5 nanometers. Where you saw that Intel's at 10 nanometers, this one's actually at half the size already. And Intel's been having trouble getting it that small. M1 chip. There should be like a short video talking about it. Anyways, I can't really find it, so it was like an official Apple video. I don't know why it's so hard to find. Anyways, okay. We'll just maybe watch that next time. Or you could find it and watch it. But yeah, a lot of companies have got even smaller than the 10 nanometers. And then this was like a video talking about logic gates, but I thought maybe we don't need to go that deep into it. We're going too deep into it. After all, this is a class for just business applications, right? Or not really for learning about how computers work and all that. So it might be a little irrelevant. Anyway, so let's take a break from PowerPoint because we've covered enough. You guys know what your final presentation is going to be. Just create some presentation. You're going to have to share your screen just like I am. And you're going to have to turn on your mic and share your presentation with us eventually. So just be prepared for that. We've talked about Microsoft Word, talked about PowerPoint, we've talked about Excel. There's one more that we haven't covered much, and that's Microsoft Access. So I think we should start looking at it a little bit. So I'm just gonna minimize this for now. And I just wanna open up Microsoft Access and just look at it just very briefly. Access. So Microsoft Access is Microsoft software for creating databases. A database is just a place where you can store a bunch of data. For example, customer names, customer transactions, or it could be for, I don't know, reporting incidents in the company, case numbers, details, the employee that was involved, employee IDs, the dates. So all these things that need to be saved and tied together, this helps you manage that. kind of like Excel, but it's got like basically some more built-in tools than a basic Excel table, right? In Excel, we can create tables. We can also do it in here in Access, but we can also do a little bit extra with tables. And I'm just going to open Microsoft Access and I'm going to choose blank database. And this is what you're going to see at first. It's Microsoft, so it's part of the Office suite, so they've got the ribbon just like the others. They've got the Home tab. You can do things like change the font and everything in the Home tab. And by default, when you first open, you're going to see table 1. And since this is all about creating tables and managing table data, of course, you have to have at least one table open. But you can close it and you'll just see blank screen here. If you want to create a table, you can go to Create and click on either Table or Table Design. So Table will just create a new blank table. You can define the fields directly in the new table or open the table in Design View. And this one, it says create new blank table in Design View. You can add fields, set indexing options, and perform other advanced table design tasks. I'm just gonna click Table and pretty much see the same thing, Table 1. And it's gonna have these fields on the top. It only has one right now called ID, and I can add another one. And you can choose the type of data that's going to go in there. So if it's like a first name, last name, you're probably going to want to choose a short text. And then for numbers, there's numbers. For longer text, there's long text. Date, time. For example, if I'm creating a table for, I don't know, a list of my students, I'll probably have short text and call this first name. Add another one that's short text and say last name. And I already have an ID here, but this is like the built-in Excel ID that's going to be required. It's like a unique identifier, because a lot of times when you create a database, you want to tie that database, or you want to tie tables together. Like I have a table called table 1, and maybe I call this, well, if I want to rename it, first of all, I think I have to save it first, so click save here, and I'll call this student information, right? So if I have a list of students, I probably want to have just a basic student information table where it's just their first name and last name and their student ID, and also a unique identifier. I don't know what else I might want to include. Let's see, first name, last name, maybe like an enrolled status. So enrolled. Oops, I meant to add that as the field name. So double click enrolled. And I guess that's it. First name, last name, ID. Even though I have a unique identifier, maybe I don't want to mess with the unique identifier, because these unique IDs will be generated automatically for each table, just so it makes sure that it's unique. It's not going to be something that already exists. So I'll also have student ID as short text. Okay, so I've created my table headers first name, last name, enrolled, student ID, but I haven't actually added any data. So there's a couple ways to add data. I could just type it directly in here. Like for example, Hubert Cumberdale. And for enrolled, I can either say yes or no. But since I'm going to be typing yes or no, there might be a better way to do that, right? Instead of manually typing yes, no. Student ID, I'll just put some fake ID, like C200134, some random number. Okay, and you can see here, my ID is 2 for Hubert Cumberdale. If I add another name, it'll automatically create a new one. It'll probably say 3. So let's say Arnold, I don't know, Schumacher or something. Schumacher. Enrolled, no. See something else. You can see that one's 3. So you can view a table like this, and right now we're in the default view, or actually it's not the default view. We're in datasheet view right now, but you can switch to design view, and what design view will show you is the field names, so ID, first name, last name, enrolled, student ID, and the data type. So it's kind of like a more detailed view of your headers and the type of data that they contain. So you can see these are all short text and lets you change it and stuff. But it also gives you some other properties. Like you can see, okay, so for enrolled, I chose short text, but that's going to be a yes or a no, right? We can, instead of short text, which lets me manually type it in, I could make it with the lookup wizard, which will let me basically choose a value of either yes or no, and be kind of quicker when entering data. But before I do that, let's also look at so down here on the bottom of the screen, you'll see datasheet view, design view. You can switch down here also to either design view or datasheet view. And on the left side here, like if I close this, the left side here shows me for the current open file what I have available. And it looks like I've only got a single table available. I can double click on it to open it again. But you can create other things here. One of the things we can create, if we go to create, we can look at, say, I think it was query design or query. I don't know if it matters. Yeah, well let's do query wizard because it says show the query wizard, which helps you create a simple query. So we'll click on that. Simple query wizard. Say okay. Hopefully this will walk us through and make it easy. Okay, it says which fields do you want in your query? You can choose from more than one table or query. So I've got this table, student information. So that's the only choice I pretty much have here. Table, student information. And then what do I want in my query? Let's say, I guess all of these. We'll just click this little arrow to add them. So next. And then student information query, yes, finish. Okay, so now we have something called a query, which looks pretty much the same. A query is just like a selection of data, and this is like a visual representation of it, but since I chose to show everything, that's why it's pretty much everything from here, because I clicked that little arrow. So for this query, I wanted to see everything from student information, so it is showing me everything from student information. um, if we go to design view on this, we can uncheck stuff that we don't want to see. Like for example, I don't want to see the student ID and maybe the last name. I can uncheck those. And then I have to save it, so I click this save button at the very top corner. And then we can close this. Oops, close that one I meant. And now you can see it doesn't show the last name. Still shows the, oh yeah, it shows the student ID, but I made it so it doesn't show the unique ID. I didn't say don't show the student ID, but we can say that too. We could uncheck that, save it, go back to datasheet view, and you'll notice for the tables, I have datasheet view and I have design view. It's either an object bound to table is open or blah blah blah. To open table, read only, click yes. To open, read write, click no. Make sure table, all objects bound to it are closed. Okay, I guess I can't open it while I have the query open. So I can only open it in read only, or so here's the read only view, but I'll just close it and make sure I close this before opening this again. So for this, we get datasheet view and design view, which shows us the field names and the data types. For the queries, oops, I can't open it again until I close this. For the queries, we have a third view. We have SQL view. So we still have datasheet view. We still have design view, which lets us check and uncheck which ones we want to show. But we also have this SQL view. And SQL is basically a query language. So even if you're not using Microsoft Access, you might be using a different type of database. For example, the databases that you create for websites. And I actually have some software here, and I've made you guys install this if you've taken some of my web classes, but this Apache and MySQL, if you open these, localhost slash PHP my admin, and I have this installed on my computer, that's why I have this, but you might not have it. So but here you can see I've got databases. These are all the databases I've stored in my computer. For example, LAPC records, right? I've got all these different tables, and I can do queries here as well. And a query here is in the same language as a query in this one. So for example, let me see if I could zoom in on this. No, oops. Yeah, unfortunately I can't zoom in so you could see this, but it says select. Well, let me just copy paste it. Paste that in there. That's what it says. Select, and then in brackets, student information, first name, comma, student information dot enrolled from student information. It's basically saying, select that data, the student information data from student information table. So the table name is student information. The first name, last name, enrolled student. Those are these here: first name, enrolled. So since I'm only trying to find the queries that you see here, first name and enrolled, my query in SQL view is only looking for first name and enrolled from student information. And you could pretty much type something similar to that in this, for example, in this PHP my admin. It would work, but if I try to do it now, it's not going to make sense because I don't have a student information table. So it wouldn't really work if I tried to do it here. But I could search for my existing tables. I could say select basically all from exams. Anyways, SQL is a whole language that you'd have to learn in if you're going to be like a database programmer or something. So it's not something we need to get into, but that's just what SQL is. It's basically, instead of doing it the easy way with design view, just checking and unchecking, you'd have to manually type what you're trying to select. Okay, so access is basically that. It's for creating tables. You can connect tables together, so you can update tables. Oh, we didn't create a form. So we got tables, queries. We can also create a form because, as I said, one way to change or add data here is to type it in manually. I mean, you're still going to type it in manually the other way, but I guess the user interface is not that nice. You have this whole list and you have to find the cell that you want to put the information and type it in. But we can also do, we can go create, we can create a form. We can choose create form, create a form that lets you enter information for one record at a time. Or we can choose form design, create a new blank form in design view. Design view, you can make advanced design changes to forms such as adding custom controls, types, and writing code. Or we could choose blank form, create a form with no controls or format. I'm just going to choose blank. Okay, so our form right now has nothing in it. No fields available to be added to the current view. So show tables and student information. We can add the student information data into this form if we wanted, but we gotta go into design view, which shows us like this grid. And so a form, you guys know what a form is. It's something with inputs, with labels, and then submit. That's what a form is. So basically with Access, you can create a form for this stuff here, the ID, first name, last name. So we could create a form that says, okay, if you're adding a new person, first name, enter the first name, last name, enter the last name. So it basically makes this just a little bit nicer looking. Let me go back to that form again. Blank form. Oops, I already have it. Form 1. So I can select like ID, for example, add it in here. You can say ID, first name, and we can design, because I'm in design view, lets me drag the fields around. Enrolled, student ID. I guess the only one here we wouldn't want to mess with is the ID, because that's going to automatically generate. So I'll delete that one. And then let's try to align these. Let me see if I can do alignment, format. I don't know if it could see it like shapes. Yeah, we could align it like that. Anyway, so this is design view, but let me switch back to the regular view. I think I have to save it first. Save this as student, or I'll call it new student form. say OK. And now I can, well, let's go into layout view. So this is what the form will look like. Oh, it doesn't have a submit button, but we can add that as well. So for adding a button, I forgot how to do it. I think it's under create. Or no, it's under design. One of these is a button. It's this one, I think. We could draw a button. What action do you want to happen when the button is pressed? So it's nice that it walks you through all this stuff, so you don't have to like create macros on your own. I want this to record, let's see, record operations, save record. I want it to show me some text, save record I want it to say. Meaningful name will help you refer to the button later. What do you want to name the button? Save student. Finish. Okay, now we've got this button here. Let me go back to design view so I can design this a little bit nicer. Put this down here. And oops, save it again and go into the other view. Let's see, we've got design view, layout view, and form view. So I want to be in form view if I want to actually see what the preview what the form would look like. So maybe I shouldn't call this new student. It's already showing me an existing student. Let me see if I can type in a new name. Bob Brown. Just put another random ID here. It should be numbers, I think. Not that it matters, but save. Okay, once I save it, let's go back to my table, student information. Now you can see it's Bob Brown here. So with that form, I changed the name of the student. So I called it new student form, but this is more of a edit student form. But we can click these arrows on the bottom to go through the records. Right now I've only got 2, so it's just Bob and Arnold. But I can click the little arrows to change their data. It's just an alternate way of doing it instead of doing it from here, clicking here and changing it. But anyways, I think I talked a little too much without pausing to let you guys play around with it. But go ahead and try to create a table on your own and try adding a query or a form. But it's break time, so we'll come back and I guess continue working on that. But there was also this other thing I wanted to do with you guys, which is I thought was pretty interesting, which is creating a a logic gate. Basically, we're creating a very basic calculator, and I wanted to show you this because computers work with zeros and ones or on and off. And here's something I built using on and off to calculate numbers, and I'll show you how to make it when we come back, I guess. What's cool, the access or the logic gates? Yeah, that is cool. That's why it's kind of unrelated, but I still want to show you. I mean, it is related. You guys are learning about computers, so we'll learn how computers work at the most basic level. All right, so break time. be back around like okay, so Access lets you create tables, lets you create queries and forms for the tables, for updating records. And you can also limit what capabilities people have when accessing these. For example, these arrows at the bottom. Let me see if I can remember how to change that. Might be under design. No. Let's see. Yeah, so yeah, it's under, we have to click on design and then property sheet. So under property sheet, we can look at the format, the data, the event, other, all. I think under format, data, format. We have to go to design view and I guess click on the table itself. And where is it? Allow, yeah, so we've got all these permissions we can control here, like allow form view, allow datasheet view. Navigation buttons, so that would be the buttons at the bottom. If I say no, and I save it, and go back to the regular view, you can see there's no longer arrows here for me to go to the next record. I'm stuck at Bob over here. And you can create multiple tables. So right now we've got our first name, last name, enrolled, student ID, and then a unique ID here, either 2 or 3 for Arnold. Let's just add like one more record, Susie, Williams or something. Enrolled, yes. Let's say G something. For the student ID. So we could create separate tables. You can go create table. Now I've got a new table. I haven't saved it yet, so it's just called table 1. But maybe this is table for like maybe the classes, different classes that are available. So maybe we have a course name. Sorry, that's the field name should be course name. And the first course, maybe it's CGD 200, let's say. And then what else? For each course, maybe we have a start date. And then we can, since I chose, well, did I choose date for this data type? I think I did. So I can choose from this calendar a date. We could have a end date, so another date time, end date. Choose when that course is over. Maybe it's the next month. And maybe well, this wouldn't be the course. Maybe this would be like the sessions. So this session is CGD 200, starts here, ends here, and maybe it has a list of students or something. I don't know if that would be the correct way to do it, but you want to be able to link the students from the students table to each session. Now, I already did all of this for the LAPC website I did, but it took a lot of thinking and figuring out. You got to design your forms, your tables. You got to do it as accurately as possible when you're first designing it, because you could later change stuff in here, but it becomes very complicated. So trying to figure out the correct way to organize your data is important. It's possible to create a very large table that lists every student and then lists every grade they have along with their student name, last name, like email and everything. But it when you have very large tables with all that data, it becomes more complicated or difficult to update things. It also slows down the database. That's why you break it up into smaller tables. Let's go to, just for reference, because I forgot how I did this. But when I created a table for sessions, what do I have here? So I've got session ID, subject, course. Well, I don't have subject anymore. I've got course ID, instructor ID, start date, end date, time period, assignment percentage. Oh, and I guess these are how much everything's worth, like assignments, how much they're worth, how much our quiz is worth. So I included all that data here. And then I've also got, well, yeah, so this one's not exactly linked to the students. So the one that would be linked to the students, maybe the grades or the exams. Yeah, so if I have exams, I've got exam IDs. I've also got a student ID. So maybe if I had an exams table, that's where I would link to each student ID. So let's go back. So instead, let's make this the exams table. So this could be the exam ID, the one. Oops. And then this would be the exam, or the student that the exam is for. Student ID. And that's the one that would link to the other table. And it would be good to, instead of having this as just like a simple text field, to modify it. into something where I could only choose from the list of students I already have. Same with the, let me close this for a second. Let's do it with this one. It's more simple. The enrolled, yes or no. Right now, it's only going to be either a yes or a no. So it makes more sense to make this a choice. So I can choose for this data type. Let's see, I right click on it and go to, I guess I can't delete it from there. I can't edit it from here, so I might have to go into design view. Yeah, so for enrolled, instead of short text that I have to manually type in, maybe I'll do lookup wizard. And then for lookup wizard, it's gonna say this wizard creates a lookup field which displays a list of values you can choose from. That's what I want. I want to be able to choose either yes or no. So how do you want your lookup field to get its values? I can say I want the lookup field to get values from another table or query, or I will type in the values that I want. Since it's yes or no, I'm not going to need to get yes or no from another table, so I'll just say I'll type the fields that I want. So I'll say next. And so it's either going to be yes or no. And what label would you like for your lookup field? Enrolled is fine, I guess. Do you want to store multiple values for this lookup? No, so I won't check that. I'll just say finish. Okay, now we go back to, well, let's save it first, save. So now when I click on enrolled, I'll either choose yes or no instead of typing it in manually. So in the same way, if we had maybe a student ID here, well, in this case, this is the students table. So here I wouldn't choose from anywhere else because this is the source for student IDs. But if I have another table, let's create that table again. Create table. So this one, maybe here I'll say this is supposed to be a calculated field. Well, no, wait, no, not calculated. Lookup and relationship. So here I'll say I want this lookup field to get the values from another table or query. And then I'll choose table student information. And I want to look up the student ID. You can sort records. I'll just sort by, it doesn't matter. I'll just sort by ID. Next. And so there's a preview of my list of student IDs. I'll say next. What label would you like for your lookup field? Student IDs, I guess. And finish. And call this exams table. Okay, so here now I can only choose from one of the student IDs that I have. So each student, then I could add like I guess a number for their score. And I don't know what else I would need, but I mean, in here I've got exam ID, I've got the session ID for which session it was for, the student ID, the exam number, and the score. So maybe I also want a session ID, but for that I would have to connect it also to a separate table called sessions. So you can see how I'm already requiring a bunch of different tables. So here I don't want to just type in a random ID for a session. I want to be able to choose from an existing list. So maybe for now I'll just save this. Field name you enter does not follow. Okay, well, I don't want to enter anything there. Just save it. Okay. Close that and close that. So I've got two tables and they're sort of linked because my exams, my students table feeds my exams table for the student IDs. And I could create a separate table for sessions and all that. But I don't want to get too deep into it right now. Maybe next class we'll look at this more. For now, let's look at the alternative. If you don't have Microsoft Access, you have OpenOffice. With OpenOffice, you can also create a database. Click on database here, and it's going to be a little different than Access. It says create a new database, or I can open an existing one. I'm going to create a new one. We could connect to an existing database, but I'll just say no and continue. Do you want to register the database in OpenOffice? I can either say yes, register, or no, do not register. That just means if you register it, then this database that I create is going to be available in all the other OpenOffice programs. Like if I have OpenOffice Calculate, which is basically this OpenOffice version of Excel, I could link some of the tables that I create over there to the tables that I created in this database. But you can always do it later, so it doesn't really matter. But I'll just say no, and then it says open the database for editing. Finish. Gotta save it. I'll just save over this one. Okay, so here it's kind of similar. Like on the left side, you have your tables and queries and forms that you've already created. But to create them, I had to go under create and choose which one I want to create. In OpenOffice, it gives you options to create them from the left side over here. So if I want to create a new table, I could do create table in design view, or create view by specifying the tables. No, let's just do use wizard to create tables, because that's probably going to be the most helpful. So category business or personal. And then, well, I guess it just gives you a list of possible fields that you might want. Let's try personal, and then let's just do accounts. So account ID, account name, account number. But what if I want to create my own? I guess for that, I would not use the wizard. I would have to do the other one, create table in design view. Let me try that. Yeah, so here I could just type it in manually, like field name. Well, we want our ID here, or the primary key. This is the one that has to be unique so that you can tie it to another table. So no other value in this table should match this one. And I want it to be text varchar. So instead of long text, short text here, you get some other names for these, like text varchar. Text fix. I think this lets you, I don't know exactly what the difference is, text fix or varchar, but normally I do varchar. That just means it could be various characters. It could be numbers or text. But maybe since it's a primary key, I'll do number. And then down here we can say Entry required. Maybe not, because it's going to be the primary. It should be added automatically. And let's just add another one. Student, or let's just say first name, text varchar, last name, student ID. And I'll let those all be varchars. And enrolled. This one, let's see if it gives us a choice. Well, yeah, it gives us a yes, no boolean, which is the same as choosing either yes or no. So we'll do that. And I guess now we just have to save it. Oops, what am I doing? There we go. Save it. Call this student information. No primary key. Should a primary key be created now? Yes. I thought I created it though. How do we make this a primary key? Tiny integer. It might be one of these here. Date time, float, small. It's none of these. Let's just save it. Maybe it'll help us do it. Student information. Say yes, create the primary key. Okay, so it just did it for me. So maybe now that I have that, I'll just delete this one. Can we press delete? Yeah. Okay, save. I should probably do auto value for this. That means it'll increment automatically every time I create a new one. So it'll start with 0, 1, 2, 3. And it says length 10 characters. So I guess it'll create 10 character IDs for me. Anyway, save that. And let's, I guess, can we close this now? Yeah, so now it shows me my table down here. It says tables, student information. I can double click on it. And now I get first name, last name, student, and enrolled. So I can put in names here. Like Bob Williams. Student ID, which I'll have to type in myself. For enrolled, it's giving me a text input, but value too long. Okay, so that's the one where it's supposed to only let me do yes or no. So I don't know if I have to put a 0 in there for no, and maybe a 1 for yes. Usually a 0 means false, 1 means true if you have Boolean values. So that's why I guess it's letting me do 0 and 1. Let's save that and close it. So we can also create queries and forms here. So let's try creating a form. Create a form and let's use the wizard. Okay, so it's gonna get table student information. That's good. There's gonna be a form where I want to be able to enter student name, last name, ID, and enrolled. Let's click next. We could add subforms. I don't think we need a subform, so I'll just click. Let's go next. I guess this gives you some more options. Arrange controls. We can Well, this is kind of cool. I don't know if Access had it, but lets you choose the design default view. Do you want it like this or like this? Maybe I'll do it like this. Simple, and say next. Let's see what all other options we get. This form is to be used for entering new data only. This form is to display all data. I think let's do one where it's used for entering new data only. Click next. Apply styles. We can choose a color. Let's go with I don't really like any of these, but let's do light gray, I guess. 3D look, no border for the button, for the form inputs, flat. Let's just go with the 3D look. Next, set name, name of the form, student information form, and finish. Okay, so now we've got this student information form where I guess I should be able to insert new data. So let's say Arnold Palmer. Give it random ID, enrolled. So either yes or no. So either a 0 or a 1. And I don't have a submit button. Not sure how we add a submit button to this. Let's try closing this. Let's say save, yes. Let me see if it updated it. Oops, not this one. Let's go to tables. Yeah, it actually added it. So all I had to do was close it and save it for the new record to be added. But it would be nicer if we had a button. But I'm not sure if we could figure that out quickly. Let's go form. How do we go into design view of this form? Edit. Let's do insert. No, that's not gonna work. Properties, I don't see anything. Styles and formatting, gallery, that's not gonna help us. What about all this stuff? Form design? Oh, down here at the bottom, I might have something. Maybe I could use just a basic shape, like draw a rectangle. I think I might have to assign macros, so it might not be as easy as doing it in Access, where it just lets you choose what you want the button to do. So that might be a problem. And I don't think I missed any step where it did ask about buttons. So what if I create a new form? Use with the wizard again, and let's say add all of these. Next, arrange controls. Yeah, it doesn't really give you an option to add a button in here. Set data entry, apply style, set name. Yeah, it's not in there, so we didn't miss it. So we gotta figure out how to add a button through here somewhere. Open design mode. It's not doing anything. Yeah, I guess I should do a little more research on figuring out how to add a button here. For now, we could just add the new data. Let's say Bill Nye Can we close it and save it? Yes. Go back to tables, double click student information. There's Bill Nye. Yeah, so we're able to add data, but without the button. So I'll figure that out next time, I guess. For the rest of class, well, let me give you guys like, I guess 5 minutes to just play around with either Access or what's this one called? OpenOffice Base. If you don't have Access, just save that. And if you have any questions, you can let me know. Nacho Libre. But I wanted to show you guys this thing. It's pretty cool. For this, I prepared a Excel sheet here. I'm gonna I'll save this. I'll give this to you guys so you can look at it. I don't know if I changed anything, but save. Where did I save that? Not this one. Okay, so what we're building here is called a full adder. We'll first make a half adder and a full adder after. And it's basically a micro circuit that lets you calculate binary numbers. So we'll look at it step by step. Let me just add this to the OneDrive. Let's see, CIS. It's not really an assignment, so I'll just put it here in the main folder. And I'll share it with you guys. So you should be able to download this. How can I enable combined shape in my PowerPoint? Well, first you have to draw two different shapes. So let me create a new slide so I could show you. Just delete this stuff here. So go to insert shapes and then add a couple shapes. So go back to here and add another one. And then you can select both shapes. Oh, you have to shift select it, I guess. And then right click. Actually right click doesn't give you the option. You have to go to shape format, merge shapes, and then you can do a union, a combine, a fragment, intersect, or a subtract. So for this thing here, this shape that I created, I just used like 3 circles. I just made one a little bit different shape. So I did it like this. Got one shape, squished it down a little bit like that. And let it overlap a little bit. Make this a little bigger maybe. Here, let me turn off the fill so you can see it more easily. Let's get rid of the shape fill. Let's do no fill. So there's my shape right there. And I guess one more circle. And let me take out the fill again. So yeah, I basically got it overlapping like this. So I want this to be solid and I want these to be solid and I want this part in between to get cut out. So I select these, merge shapes, and where is it? I might have to fill it, or I might have to rearrange them. Let me see. Let's put the fill back in. Shape format, shape fill. Merge shapes. Which one was it? I guess I could do this and then make this solid again. Or make them all the same color. Let's I'll use align to make sure they're centered in the middle like that. Okay. And get rid of the outline. No outline. And that's pretty much it. And then I could select both of these again and do a union so it becomes one shape. And then if I want to cut out like the back part, I'll put another shape like this on top of it. Select both and do another. Let's do this time. Let's do subtract. But I think I have to rearrange it. Put this in the back. Then select it and do a subtract. Uh-oh. Subtract. Wait, why is it doing that? It's showing me one thing here and giving me a different result. Guess I could combine. No. Let's try sending this to the back. Doing it again. That's weird. Either way, it cuts out this instead of this one. Bring to front. Should look like this, but oh, there we go. This time it worked. I don't know why it wasn't working the first time. And then we could reshape that. So that's how I created this here. And then you can just insert an image into it. Okay. All right, let's look at that Excel file that I uploaded. So this one. I shared it with you, right? Yeah, full adder. So download that full adder so we could look at it together. Probably don't have enough time today to do the whole thing. But we'll just get as far as we can. Get everyone download that and open it. Start with the first sheet. Okay, so to be able to understand how this works, first you have to know how to add binary numbers. So here's regular decimal numbers, how you add 15 plus 6. If you have 5 plus 6, you get 11, right? So you carry the 1 up here, and then you add it in the next column. So 1 plus 1 is 2, and you put that there. Well, in binary, if I was going to add 15 plus 6, 15 in binary is actually 1, 1, 1, 1. And 6 in binary is 0, 1, 1, 0. And the way you figure it out is, right here I listed 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3, and 2 to the power of 4. So 2 to the power of 0 is 1. So if you have a 1 in that 2 to the power of 0 place, then you get a 1. You get number 1. 2 to the power of 0 is 1. 2 to the power of 1 is 2. So if I have a 1 here, that's 1 plus 2. So we're at 3 already. 2 to the power of 2 is 4. So 1 plus 2 is 3, plus 4 is 7. And then 2 to the power of 3 is 8. So 8 plus 7 gives you 15. So that's how that works. So the 6 also, if we have 2 to the power of 0, well, we don't have a 1 there, so we don't count that one. So it's 0. But 2 to the power of 1 is 2, so this is 2 so far, plus 4, plus 8. Wait, let me see if that's right. No, we don't do the plus 8, that's a 0. Just 2 plus 4, we get the 6. So then you add it up. Well, first try to understand that part, and then adding it is basically the same, except since you only have two numbers, either a 0 or 1, if you do 1 plus 1, you can't just write 2 here because there's no 2 in binary. So 2 in binary is 1, 0, right? 2 to the power of 1, 1, 0. This is 2 right here. 1, 0 represents 2. So 1 plus 1 is 1, 0. So we carry the 1 here, put the 0 here. And then 1 plus 1 is 2, plus 1 is 3. And 3 in binary is 1, 1. So we put the 1 here, carry the other one. And then 1 plus 1 is 1, 0 again, so we get 1, 0. So this should add up to 21. 1, 0, 1, 0, 1 is 21. You can check online binary converter. I'll copy paste this here. And we can check what is 1, 0, 1, 0, 1, 1, 0, 1, 0, 1. Convert, we can see it's 21 in decimal. So that's how binary numbers work. That's how you calculate them, do addition on them. So what we're going to make is a calculator using just logic gates that can do this for us. That makes sense. Let me let you guys absorb that for a couple minutes. If you don't, I know binary is confusing, but just stare at it and then you'll kind of get it. So in binary numbers, it's just basically everything to the power of 2. And the further you go left, the higher the power. So you start with 0, and then 2 to the power of 1, and increase from there. So for bigger numbers, you get 2 to the power of a higher number. And each of these is a bit. A 0 or a 1 is a bit. So that's what your computer stores, either these zeros or these ones. Any questions? Okay, so binary numbers, for the number 1 in binary is just a 1. For the number 2 in binary, since there is no 2, binary is either 0 or 1. In decimals, you get from 0 through 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You get 10. That's why it's called decimal. In binary, you just get two numbers, 0 or 1. So to get 1 is just 1. To get 2, there's no 2, so you have to add something else to this. So you do 1, 0. Okay, the 0 represents 2 to the power of 0. And the 1 represents 2 to the power of 1. So 2 plus 0 is 2, so this represents the number 2. 1, 0. To get 3, you have 2 to the power of 1 here, which is 2. You have 2 to the power of 0, which is 1, but since it's a 0, we're not counting it, so this is just the number 2. But if we add that, we make it a 1 instead of a 0. Now it's 2 plus 1, which gives us 3. So 1, 1 is 3 in binary. 1, 1, convert number 3. If you want the number 8 in binary, we already know 2 to the power of 3 is 8, right? 2 times 2 is 4, times 2 is 8. So the number 8 in binary would be 1, 0, 0. Right? So in the the zeros place we have 0, in the ones place we have 0. Wait, do I have that right? I think it's 0, 0. Sorry, this is the number 4. This would be the number 8. 2 to the power of 3. So you get the 8 there. Nothing for the other ones because we're not counting it, because we're only counting up to 8. So 2 to the power of 3 is already 8, so it's just 1, 0, 0, 0. If we added a 1 here, that would be 8 plus 1, which is 9. So 1, 0, 0, 1 is 9. And if we added, instead of a 1 there, we put a 1 here. This is the 2's place, so this is where it's 2 to the power of 1, which is 2. So 8 plus 2 gives us 10. So 1, 0, 1, 0 is the number 10. And then 1, 1, 0, 0, 0 is 8 plus 4, because 2 to the power of 2 is 4. So 2 to the power of 3 plus 2 to the power of 2. 8 plus 2. 8 plus 4. That gives us 12. So 1, 1, 0, 0 should be 12. 1, 1, 0, 0. 12. Make sense? In the next sheet, I created a table for a half adder, and it actually calculates. There's a formula here that changes decimal to binary. So first it'll calculate here sum of C6 to D6. So it'll calculate what these numbers add up to. And then it'll convert it to a binary number. So 0 plus 1 is 1. In binary, that's 1. 1 plus 0 is 1. So binary, it's 1. 1 plus 1 is 2. In binary, that's 1, 0. The next sheet gives you a carry, which is going to be our third bit. And this is required if you want to create a full adder. And with 3 bits, we can do maximum of 1, 1, 1, which in binary gives us 3. It's 1 plus 2. Wait, I got that wrong. Yeah, 1 plus 1 plus 1 is 3. In binary, that's 1, 1. So 1, 1 is, again, 2 to the power of 2. 2 to the power of 1, which is 2, plus 2 to the power of 0, which is 1. So you get 3. 2 plus 1. Two to the power of 0 is 1. 2 to the power of 2 is 2 to the power of 1 is 2. 2 to the power of 2 is 4. So That's just how it works. The further you go left, the bigger the number. So 1 is just 1, but if you had 1 0 0 0, then this is the place for the 1, this is the place for the 2, this is the place for the 4, this is the place for the 8, and then 2 to the power of 4 is 8 times 2, so this would be the 16. So this 1 0 0 0 0 with 4 zeros, that's going to be the number 16. Yep. I think if you just practice or just think about it and try changing these numbers to get a different decimal number, and you'll get the binary number for that. Well, actually, the max here is just 3, so you can't really go higher than that. It's either 1, 2, or 3. With just 3 bits, that's the highest number you can get. I mean, if you're just adding 3 numbers, sorry, 3 ones. If you're adding 3 ones, the highest you could get is 3. Okay. That makes sense. And then here I drew on sheet 4 the logic gates that you're going to need. So in computer science, there's something called gates, and you can get different types of gates from transistors. So there's these two are exclusive OR gates. So that means let's practice a more simple way. Let me give you a link to this cool website here. Logically, copy, paste, go to that website, and then let's create some logic. Is everyone on this site? And yeah, here we could zoom in with the mouse scrolling, and then you could click this button here to move around. And on the left side here, we've got input controls, output controls, logic gates, and some other things. But for this, we just need input controls, output controls, and logic gates. So input controls would be like a switch to turn on power, basically like a battery. So this is like a source of power. I could turn it on or off. Okay. And then for outputs, we could have a light bulb to see if it's either turned on or on, and we could connect these together. So now it's off, now it's on, off. I might have it backwards. I think this is off and this is on. I don't know. This looks like it's on. Anyway, so I could turn it on or off. So try creating just that, turning it on and off. So when it's on, that means we have a 1. If it's off, we have a 0. Okay, let me zoom in on this. Scroll this way. So 0, 1. Now let's add our logic gate. So there's different types of gates, but the ones that we're going to need are the AND gate, the OR gate and the exclusive OR gate. So if it's an AND gate, this means that well, we could connect this to here. Oops, why can't I? Oh, I'm on this tool, that's why. Can connect this here, but this is gonna need two power sources because it's got two inputs, so we need a second input. So there has to be electricity coming from two places. So with the AND gate, AND means both have to be on, right? So this and this have to be on for this to turn on. So if it's only one turned on, it's not going to work. They both have to be turned on. That's a AND gate. And then let's create an OR gate. So get that, get our light bulb again. Alright, so with the OR gate, I could either turn this on, or this one, or both. Even if both are turned on, it's still gonna turn on. So if you have at least one turned on, the OR gate will let electricity go through. It's a gate that opens if either one or at least one is turned on, okay? The AND gate only turns on if both are turned on. And then the exclusive OR gate. So this is the exclusive OR. I'll put a light bulb here, connect it. Put two more switches. The exclusive OR is kind of like the OR gate, except it only works if only one is turned on. It has to be one or the other. It can't be both. Okay, so one opens the gate whenever both are turned on. One will open the gate if either one or both are turned on. And the exclusive OR will only turn on if only one or the other is turned on, not both. Make sense? Alright, so this was really hard for me to figure out. So I don't know, maybe some of you have like a very high IQ and you can figure this stuff out more easily, but just using this logic, knowing that you can use these three different gates, using these somehow you should be able to figure out all these different cases here. Well, let's look at the half adder first. Case 1, if it's both bit 1 and bit 2 are 0, if they're both off, we get a sum of 0, so nothing, the light doesn't turn on. And we don't carry anything out. Well, for now, we haven't created anything to represent the carry. So let's just look at this scenario here with the sum. Okay, if both are off, sum is 0, so it's off. If one is on, then sum is 1, so it doesn't matter which one is on. If both are on, the sum is 0, but we get a carry out. Okay, but let's just focus on this part right now, creating that with the gates. So I'm going to delete these. So we have a light bulb. This is going to represent the sum. So let me add do I have a label here? I think there should be a label. Yeah, label. So this represents the sum. Oops. So that represents this here. So it's either going to be a 0 or a 1, on or off, depending on the 2 bits that we have. And the 2 bits are the 2 switches. So we could label these two, I guess. Bit 1, bit 1, bit 2. Okay, so now we have to figure out how we could turn this on. Well, this one's easy. It's only going to be on if one or the other is on, not both. So we could get any of these cases using just the exclusive OR gate, right? So if one is on, we get a sum. If this one's on, we get a sum. If both are on, we get 0. That's 1, 2, 3 different cases that we're covering. We got 4 cases here though. We got we got 1, 2, 3, 4 cases. So that's all 4 cases. Both off, one on, the other one on, or both on. We're able to get the sum. So now we have to think about the carry. The carry will be represented by another light bulb for now. Carry. Actually, I need a label. Let's call it carry out because there's also a carry in. So this is going to be carried out. Okay, so still using these same 2 bits, we have to figure out how to get these states here. So if it's only one on or nothing on, it's going to be off. If it's both on, then we get a carry. So that means we need a AND gate. If both are on, then this turns on. Okay, and we could, I guess, arrange this lamp here, this one here. Oops. And this could be representing a binary number with 2 digits, right? So 1 plus 0 is 1. Right? Where do we see it? Yeah. 1 plus 0, we get 1. In binary, that's just a 1. So here we just have a 1 or a 0, 1, same thing. If both are on, then we get a 1, 0, which is the number 2. 1, 0 is 2. So think of the light that's on as a 1 and the one that's off as a 0. So 1, 0. So with this half adder, we can only count to 2, basically. We can only add up 1 plus 1. But there's a reason why I call this the carry and not the the 2 position, because we can get rid of that. And we can basically make this, instead of a, so right now it's a half adder. For a full adder, we have more cases that we need to cover. We have a carry in situation. So with a full adder, you don't just have 2 inputs. You're going to have a third one that's going to be carried in. Well, for the first one, it'll just be a switch. But when you connect these together, instead of a switch, this will be basically the carry out from the last one. So making sense so far, because the rest of the next part is confusing. I'm not sure if I remember how to do it. That's why I saved this one. And we could make this look nicer with these buttons here. Do that. All right. So there's gonna be more gates involved. We're gonna need another XOR gate for sure. We're gonna need another AND gate, I think, and we need an OR gate. But let's figure this out. So far, right now, only our first position sum is there. So that's the ones. We either have a 1 or a 0. Okay, if 1 is on, then it's a 1. If both are on, it's off. Okay. It's really hard to make this look nice. Anyways, all right, so we have to figure out the third input. So if we have 3 inputs, then that third input also has to connect to the sum somehow, right? Because we're adding now 3 different numbers, getting a sum out of that. So we can't just have these 2 connected. We need this one also connected. But we got to figure out how to connect it so that it matches these cases. So if it's just one number, then we're gonna have no carry. So it's gonna be a carry if either we have 2 or 3. So there's 2 cases where we'll get a carry out. Either 2 of the switches are turned on or all 3 are switched on, and we get a carry. So having all 3 on like this, we should have, let's go back to light bulb. This should be turned on when all 3 are switched on, or if 2 of them are switched on. So that's 2 cases, right? Either if 2 of them are switched on or if all 3 are switched on. So I think, or yeah, either that or if all 3. And it doesn't have to be one or the other. So we can use an OR gate for that. Okay. But we also have to connect this to this one. Let me see how I did it here. This one connects to yeah, this other exclusive OR, and it connects to that one. Yeah, but it is connected though. So all 3 switches are somehow connected to both light bulbs. the sum and the carry. Okay. Might have did something wrong because I don't know if it was supposed to work with just one exclusive OR gate. Might have missed one condition. I don't know. I didn't label these, but yeah, this is bit 1, bit 2, and this is the carry in. And then this is the carry out. This is the sum. Alright, so we're gonna need to connect this here first somehow. I guess we could probably ignore this for now, because we need to figure out with 3 bits, how do we still get this to work the same way. Alright, so that's where I guess the second exclusive OR gate comes. So for now, let me delete the connections. Because yeah, that's easy if you're just using 2, but if you're using 3, it's a little bit more difficult. So disconnect this one too. Bit 1, bit 2. Alright, so now we gotta figure out, for this one, let's look at all the cases where the sum is 1. So it's gonna be 1 if either 1, well, if any 1 is on, but not 2, or if all 3 are on, that's when we get a sum. So if all 3 are on, or if 1 is on, we get a 1, it turns on. So this should only turn on if either 1 is turned on or all 3. So how do we get that? So that's, again, 2 cases. So I think we could use an exclusive OR. We need another exclusive OR for this one, connected to the first exclusive OR for these two. And this one, well, I don't know if this is gonna work yet. If 1 is on, it turns on. If 2 are on, it turns off. If all 3 are on, it turns on. So yeah, there we go. I didn't really think about it, but I just connected it together and it works. So you could kind of figure out why it's working or not, but I got it to work just with luck, I guess. So why is it working though? Because we have 1. So if 1 is turned on, then this is an exclusive OR, and exclusive OR turns on if only 1 is turned on, but not both. Okay? So if 1 is turned on, we get power through here, and we're still getting power through here to this one. And again, this one turns on if only 1 is on. So 1 is on, 1 is going through, so it turns on. But if we turn both of these on, this one turns off. Okay, no more power, so this turns off. Because this is an exclusive OR. It only turns on if 1 is turned on. And then by connecting the third one to another exclusive OR, we just make sure that if this is turned on, then this will be on. But if one of these is turned on, then there's, again, this is an exclusive OR. It turns on if 1 is on. But since it's connected to this one, which is also an exclusive OR, if power is going to this one, and power is going from this one to this, but it's also going from this to this, since this only opens the gate if one place is turned on, it turns off. So, but once we turn on the third one, this one now also turns on, so this turns off. So again, this becomes open because there's only one energy source coming in. Does that make sense? So with this, now we're getting all the cases for 3 bits. We're for the sum. So all that's left is now figuring out the carry. Okay, so yeah, the carry, this is the carry out. We'll talk about the carry in is basically this. This is the carry in, but for your first one, you don't have something coming in, so you start with just a switch. So you could think of it as bit 3, I guess, but once we connect these together, then this will become the carry in, which the carry out will connect to from the previous circuit. Alright, so now we have to figure out this one. When does this carry out turn on? And again, that's the carry out from here. So if we add 2 numbers, we get a carry out. If we add just 1 number, we don't get a carry out. So 0. If we add all 3, we get a carry out because 1 plus 1 plus 1 is 3. And to represent 3, we have to put 1, 1, 1, 1. So it has a carry. Alright, so for this one, it's going to be turned on if either 2 are on or all 3 are on. So either 2 or 3 have to be turned on. Which is kind of like the opposite of this. Not really. But okay, so for that, there's 2 cases, so I think we can use an AND gate for that, yes? Or sorry, an OR gate, because either 2 or 3, but not 1. I don't know, I'm just gonna assume it's a OR gate. So we need an OR gate connected to this. Because after we do it, I'll figure it out. But again, this is like some high IQ stuff, I guess. That's why I'm not good at it. Alright, so we have an OR gate. So this is gonna turn on if there's power coming from here or from both. Okay. So let's add an AND gate here. So if both of these are turned on, then this will turn on. But what about the third one? We can't connect it directly to it because, look, right now if 1 is turned on, it's going to be on, and that's not correct. If we just have 1 on, it should be off. So that's not going to be the right way to connect it. Instead, and also this, if we turn, well, no, this one's fine. If 1 is on, it's off. If both are on, it's on, and that's one of the cases where we do want it to be on. So that's fine. But we got to figure out this one. For this one, let's see. We have an AND gate. We need another AND gate. Let's put that there. So for this one, think if one of these is on, we have this exclusive OR that will only let power go through if one is turned on. And this AND gate will, I think, where does this connect? I need to double check. I wish I could remember it, but I can't. So we have the two AND gates connected to the OR gate. And then from the first XOR gate, we get some power going to this one, which also connects to the carryout. So the carryout connects to one of these. It's connected to the bottom one. This also connects to this first exclusive OR gate. Okay, and let's delete this, connect this here and this one here. So this is the correct way to do it, but well, let's see if it's working. So if you turn this on, you get a sum. If you turn this on, you get a sum. If you turn this on, you get a sum. If you turn both on, you get a carry but no sum. If you turn these two on, you get a carry but no sum. And that's so far so good. You get either two, these two, or these two, or these two. You're gonna get a carry out, but no sum. That's so far the situation that we have here. If we turn on all three, then we get both turned on. Yeah, so it works, but do we know why it works? I don't know. Maybe you can understand that last part. This part got confusing, adding that third one and figuring out the carry out. Anyways, looks like we're pretty much running out of time anyway. But the next thing you'll do is you can select all of this and convert. You could create an integrated circuit out of it, which basically just shrinks it down. And to create the integrated circuit, you got to name these. Got to name this the carry out. And this is the sum. And we also have to name these bit 1, bit 2, carry in. So this is a bit 1, bit 2, and this is the carry in. If you take all of this after naming the outputs and the inputs, you can say create integrated circuit, give it a name, and we'll call it the full adder. I think I already have one, so I'll call it full adder 2. And you can rearrange the inputs and stuff to make more sense for you. But once you do that, then you basically, all of this that I have here, I can go to my custom tab here. This is basically the same thing as this now, except without the switches and the light bulbs. It's just the inputs and the outputs. And once you have that, you can connect multiple of these together. We can rotate them. And you can take the carry out, connect it to the carry in. Carry out, carry in. And then you could create something like this at the end, where I got 4 of them connected. And each of these switches represents a number. So it's like your top numbers and your bottom numbers that you're going to add together. So just like in here, we got our top numbers and our bottom numbers, 1, 2, 3, 4 of them. So the number 15 is 1, 1, 1, 1. So I can add 1 plus 1 plus, well, that's 15 plus 0, 1, 1, 0. 15 plus 0, 1, 1, 0 gives us 1, 0, 1, 0, 1. So 15 plus 0, 1, 1, 0 gives us 1, 0, 1, 0, 1. 1, 0, 1, 0, 1. So we're able to, with 4 of these, we can count up to 30, I think. Right, because, yeah, 1 plus 15 plus another 15 will give us 30. So the maximum number we could get is 30. We can count up to 30 with this. So 30 would be 1, 1, 1. 1, 1, 1, 1, 0 should be 30 if we check here. 1, 1, 1, 1, 1, 0. Wait, I think I have an extra one. Yeah. 1, 1, 1, 1, 1, 0 is 30. 15 plus 15. Pretty cool, huh? And so computers have like some circuits in there that look just like that, and that's how they calculate. I don't know. I'm gonna stare at it more. I really want to understand exactly how it works. I mean, I got it to work, but through trial and error mostly. So all right, let me give you the sign out code.